Hello! Today I'm going to demonstrate to you how you can create a PlayStation X look for your Unity game. This will be using Unity URP. I'm using version 6. This has worked across different versions, however there are some slight differences, but for the purposes and sake of this video, it will be in Unity 6. The first thing we need to address about the PS1 and PSX style graphics is what exactly goes into them. Here I made a list. The first three are the vertex jittering, color quantization, and pixelation. And I will explain each of these. Back on those old consoles, they could not calculate floating point digits for vertexes on models and meshes. So instead they had these vertex snaps to integers on the grid. Color quantization is a sort of posterization that applies to the screen as a sort of post-processing effect, but you'll see that we'll be doing this in ShaderGraph. Pixelation is pretty self-explanatory. It takes the texture that you have for a material and it pixelizes it, or it pixelates it to a lower resolution. Dithering is a sort of screen noise that helps make the game feel lower resolution but still high quality. And then what we could do is called resolution reduction. We could do this in two ways. We can either reduce the internal resolution of the engine that we were working in, or we can reduce the resolution of the screen using ShaderGraph as well. A couple of good examples of games that do this are mouthwashing. In this screenshot in particular, you can see a bunch of these come into effect. You can see the lower resolution by some of the aliasing and the noise happening on the edges of the model, especially in the background, how illegible these things can be. You can see the dithering noise in this screenshot here on the chair. You can see the color quantization on Anya's arms and shirt, where it just seems like it's going from one color to the next color to the next. What isn't happening as much in the screenshot is the pixelation and the vertex jittering. In this game, 500 Finger Fillet, you can see the clear pixelation on the brace, the hand, the table, some of the assets as well. It's hard to tell. And especially in this screenshot, or in this GIF down here, when the button moves, you can see the vertexes and the edges of the button start jittering around. So there's actually a couple ways that you could go about making these things outside of Unity. Let's start with vertex jittering. You could actually animate each vertex in Blender or Maya, whichever you choose, for each model. However, that would be quite inefficient, as you would have to rig every vertex or whatever, or come up with some script to do that on your export, which is also not performant. So we do it via ShaderGraph. Color quantization is a sort of posterization that only you could apply to your texture as a filter or as part of the texturing process, which is totally valid and more performant. However, will take up a lot more work. And the same thing for pixelation. However, we will be doing it in Engine. It is a lot more customizable in Engine, as opposed to having to open up Substance or whatever to go back and change these values. Dithering is a more engine-specific thing. I don't know that you could do this outside of Unity. And the same thing with resolution reduction. You would want to keep these two things in Unity. So I have the scene set up. I have a plane, I have our directional light set up, and I have a model here with textures and a basic material, a standard default URP material. So what we can do is right click in our project window, go to create, go to ShaderGraph, URP, and we will select lit. You can do unlit. Both are completely valid. The difference is that lit will interact with light and unlit will not interact with light. And you can change this later after you've chosen. I'm just going to name it PSX. and I'm going to double click and it will open our shader graph in this window. I'm going to double click the tab so it full screens just like this. We have the graph inspector, we have the shader graph variables on the left. And here you can actually see in the graph settings, material lit, you can change whatever you want to here. So what we are going to do is we're going to create a couple of variables here. We're going to create VTX res, which stands for vertex resolution. We're going to create another float called TXL res, which stands for pixel resolution, and one more float called QNT res, quantization resolution. We're also going to add texture. Let's just call this albedo, which is also for color. And then we're almost good to go and ready to make our graphs. So we actually need to grab the positions of every vertex on every model in our scene. And this will be done, and this is done by applying the material to the model you want affected by it. So only the models affected will have their vertex positions read and changed. In order to do this, we can click space and type in position. Simple. Now we don't want the position of world space, we want the position of the object. What we're going to do is we're going to drag this into a multiply node, A, and we're going to multiply it by the vertex resolution. And what we actually can do is click the variable and change the default value to something like 256. And you will see a very noticeable difference in the preview. You can then go to floor. Basically, floor is a math operation that will deprecate the decimal points on a number. And then we want to divide by our resolution again. And you might be like, well, nothing has changed. What's the difference here? You'll see that if we bring it to a lower resolution, you start to notice these lines, and these are actually whole numbers, representation of whole values that our vertexes will be snapping to. Let's change that back to 256. And then let's put this into vertex position because that's what we want to change. Let's hit Control S to save, or you can hit this little floppy disk. Let's get out of full screen mode. Unity will take a second to load. Go back to scene view. You could go into your material, shader, ShaderGraph, and then click PSX. And then drag the texture up. So what is wrong here? Well, actually, we're not taking into account for the camera. As you can see, we can increase and decrease the resolution, and this is kind of the effect we want. But we're not going to change this value during runtime. What we need to do is account for the camera. How do we do this? Well, we grab what's called a transform node. Plug the out into here. Change the space from object to view space. View space being the camera. And keep it position. And then grab another transform node. And then reverse that effect from view back to object. So basically, we grab the position of the object, we take it into the camera, we do all our math, and then we take it back to the object to be read. And you will notice we now have a jittering. If we decrease this to something ridiculous, yeah, this looks crazy. And most games of the era did not do this. They had something, it was something they couldn't control. So something pretty high, something like this. There's a very subtle effect. But more games recently, especially with a more stylized look, have something crazy going on like this. But whatever your game needs. I'm going to set this to 128. Let's go back into our shader graph. So we have that vertex jittering done. Next, we're going to go straight to quantization and actually skip pixel resolution, and you'll understand why. So you want to space again. It's sample texture 2D. This allows shader graphs to read textures that you can input on your own. Grab the albedo variable and just plug it into texture. Now, if you actually click on the albedo variable and in the node settings, there is no default texture applied. If you know the object this is going to be applied to, you can set it here. However, if you want this applied to many objects, which you would just leave this blank and then assign it in the inspector. So, in the math for color quantization and pixelization is actually very similar. So what we're actually going to do is we're going to hit space and hit combine. That's what we're going to hit. I'm just going to RGB, so we can only affect the RGB values. Now this may seem a little bit redundant and confusing. The reason we do this is you still have access to an RGBA channel if you want to do other shader graph stuff, and you have access to your alpha channel for transparency. So we will just output the RGB into multiply A. We'll grab our quantization resolution, plug it in. We will actually set the default to 256 again, because that's simple. Multiply, floor, and then divide. Now what this will go straight to the base color fragment node of the output. This is called the output. Hit Control S or your little floppy disk, and we can go back to the scene view. And if you had it set to 0 and if you were experimenting, this is what your object will look like. I'm going to set it to 256. And I will show you what the changes look like. So a really low value is probably something you want. Of course, the lower you get, and of course you have to adjust. You have to take into account, you know, the darks and the lights of your object. So the lights and the darks of my object and how they look. Let's say I want something around, I think I want 16. 16 is cool. And nice quantization around the edges and the midtones, still keeping the color, but adding a lot of contrast and style. Okay, now we will talk about pixel resolution. I will go ahead and set the resolution here. And then what we actually want to do is grab what's called a UV node. Now UV is what allows models to have textures and read them. I'm not going to go into a whole diatribe about what UVs are and all that, but know that UVs are essential to reading and affecting textures, especially resolution of the texture and pixel density and stuff like that. Again, not going to go into a whole thing here. If you want an explanation, I would highly recommend watching an Abe Leal video about it. But we want to take the output and we want to split. The thing to know about a UV though is that it is an XY, it is a 2D plane made of an X and Y. So we need to get an X and Y so we can read and decrease the resolution. So we will use an R and G, which will be our X and Y. And we will then combine, actually here, here, and here. Basically what we are doing is that we are outputting a UV to be affected by the pixelation resolution variable. Multiply, blur, say it with me, what comes after, divide, this goes, there we go, there. And where this divide goes is in the UV input on our texture. Hit Control S, save. And since I had 0 pre-selected, nothing will show up. But as I increase, you can see, especially in the bottom right here, how it affects the pixels. And our image will come back to us if I go back to something like this. Higher resolution. If I take it all the way back up to its like original resolution, I think is 20. If I go to 2048, there will be no noticeable difference, almost. Okay, now let's talk about dithering. For dithering, it's a different type of shader graph. Go to Create, ShaderGraph, URP, Full Screen Shader Graph, and just call it Dither. You want to right-click it as well, Create Material, and call it Dither. And you'll notice it's not a material sphere, it's actually a plane. This is because it's a full screen shader. So double-click Dither, and we will now have access to this shader graph. We're going to start off similarly to what we did before. We're going to create 2 float values, dither res for dither resolution, and color res for color resolution. We're going to start off with a UV node, grabbing the UVs, and input it into a URP sample buffer. This node is the backbone of a lot of stylized looks in Unity's universal render pipeline. This will be inputted into other nodes, but first let's do some math. Let's grab a dither node, because would you guess it, that's what we're doing. And we actually want to put it into the screen position. And then you want to output the URP sample buffer into the dither node. By the way, set this to blitz source. Plug this into a subtract node and set everything to 0. Plug this into a multiply node. And we are multiplying by our dither resolution. I'm going to grab our output and move this over here. Now we can plug this into an add node, and we want to add our URP sample buffer. Plug this into a multiply node, into multiply B, and multiply by our color resolution. Plug it into an add node. Set everything to 0.5. Then we are going to lower. And then finally divide by color resolution. And this will be our output. hit Control S or hit the floppy disk, double click, go back to our scene, and well, where do we put this dither material? Well, we actually can go to our settings tab and click PC renderer. Not mobile renderer, not anything else, PC renderer. And there's a couple of things we can add here. We can mess with our rendering path and whatnot, but that's not what we want. We want to look for add render feature and click full screen pass render feature. Now, if you've done correctly, you should see your screen be inverted. If it's not inverted, then you likely clicked the wrong one. You likely clicked full screen pass render feature, or if you accidentally went into mobile render and nothing happened, then you're there as well. PC render, add render feature, full screen pass render feature. And now we can input a material here. If we want to put our dither material, and our screen's black. Great, what happened? We can set the color resolution into the resolution here in our material. The reason the screen is black is because we have no resolution. We're not looking at anything essentially. So we can increase the resolution and still nothing's happening. It's because we have no color. So we can change this to something like 16. Whoa. And you can look up and see that everything is kind of wonky because it's set to 0. So if we increase this, you can see how weird it gets, and it can get very difficult to look at. What is usually recommended, a very, very low number, 0.005 or 7. I'm going to go with 0.003. You can increase the color resolution if you want more colors available to you, or you can decrease it to get a sort of baked effect like that. Obviously, this being in a default scene is does not lend itself to much demonstration, but you get the general idea. Now, I do want to stress that this shader can heavily mess with your lighting and whatnot. If you have pretty soft lighting, you may have to bump up the intensity just a little bit. So just keep that in mind. What we can do is we can go back to the PC render, and we can change if we want this before post-processing, before rendering, or after post-processing. What I usually do is I do before, but it's really up to you. The look is different depending on what you need. So here we have our game view. I've moved the camera, and we can move on to this last thing, screen resolution reduction. We can do this by going to PC RP asset, and you'll see a couple of different things. This is all post-processing stuff down here, but we're looking for quality. And you can see a slider called render scale, and we can just drag this down, and you will see how our game resolution becomes really chunky and blocky and difficult to read. You can change different pixelation types or filter types. I've set this to automatic. You can also set the anti-aliasing if you want aliasing as well. I'm keeping that disabled. Nearest neighbor is really sharp, which is a nice clean look. With this low of a resolution, the artifacts for the dithering become really apparent, but also they're still pretty subtle, which is nice. If you want to change some things about your texture, I would recommend point and changing the compression to no. This just makes it so it's not blurry when it gets reduced in resolution. We can actually make a new ShaderGraph URP, make a new full screen shader graph and call this green res. I'm going to right click, create material, screen res, and click into our shader graph. So I'm here in the screen resolution shader graph with the multiply, floor, and divide nodes set up. What we want to actually do is output to URP sample buffer and set it to blit source. And then output the blit source into our color. So in order to grab the screen, we need a screen position node. And we are going to split into an RNG into a vector 2 node. We're going to output this vector 2 into our multiply. What we're also going to do is grab the screen itself, the width and the height, plug this into a vector 2, and then multiply this by our screen resolution. And basically we plug this multiply into the multiply and divide, hit save, go back to our scene view, and as you can see, a really small number has a great difference on our screen resolution. Editing Llama here. Hey, just want to let you know that in order to get this to work, you have to actually add it as a render feature, the same way you added the dithering as a render feature on the PC rendering asset. So yeah, that is everything you need to know about how to get started with making a pretty solid PSS looking Unity project. Thank you so much for watching. Yep. So next, we're actually going to skip pixelization and we're going to go straight. We're going to next.